Okay, today we will study a new lesson in integration, which is integration by partial fractions. Do you remember how to deal with this integration? Long division. Yes, it is a polynomial divided by a polynomial. So the first thing to think about is to check if the degree in the numerator, in the above, is greater or equal to the degree in the denominator. If it is greater than the denominator or equal to the denominator, we make long division. Okay, and we have learned and expect in the exam there is a question on checking if you can do long division or not. Okay, we have to have the skill of making long division. Now this problem is solved by long division, and then after long division it will be something plus, and here is some first degree. For example, it will be 3x plus 1, and here we have 4x plus x power 4x squared, and the result will be something like x squared plus 2x plus 1 plus this is the result, which is 3x plus 1 over 4 plus x squared. This is not the exact result of the long division, but I am just putting an example of what will be the result as a form. It will have this form. This is the result of the long division. This is the result of the long division, and this is the remainder, and it will be here, and this must be with a degree that is less than the degree of the denominator. Okay? Now how can I perform this integration? These terms are not a problem. We just make the power rule. I add 1 to the power and divide by the new power for each of these terms. Okay, there is no problem in these terms. What about this expression? For this expression, I have here in the denominator 4 plus x squared. Okay, and here we have. So I have here a quadratic form in the denominator, and we have learned how to deal with quadratic forms. If it was like this, or if it was even like this, 4 plus 2x plus x squared, how would I deal with something like this, 4 plus 2x plus x squared in the denominator, and in the numerator I have some first degree. I complete square. But first we check the derivative of the denominator. I check the derivative of the denominator, because if I have the derivative of the denominator, it will be just ln, or double the root. If the denominator was inside a root, the result will be double the root. Okay, so I first check if I have the derivative of the denominator in the numerator. What is the derivative of this expression? It is 2 plus 2x. Okay, so can I make this numerator in this form? Can I manipulate it to be in terms of this bracket, 2 plus 2x? Yes. First I have to make the coefficient of x to be 2. I need this to be 2 first. First I have to make the coefficient of x to be 2. How would I do this? I first take 3 as a common factor. I take 3 as a common factor. I take this out and I delete it from here, and this will be 1 over 3. This is the same problem, but I made the coefficient of x first to be 1, but I need it to be 2. So what would I do? I would multiply here by 2, then divide by 2. This is the same problem. I didn't change the problem, but I managed to make it 2x. That's a good progress for me. I made it 2x. Now I want to make it 2x plus 2. What would I do? I add 2 and subtract 2. Now I have this bracket. I have this bracket which is 2 plus 2x, which is the derivative of the quadratic form in the denominator. Okay? I have managed to make the expression in the numerator in terms of this bracket, which is the derivative of the quadratic form in the denominator, or inside the root inside the denominator. If the expression was like this, linear over root quadratic. Linear over root quadratic, I would deal with it in the same way. Okay, now after I have expressed the numerator in terms of the derivative, I separate it. I distributed in these both terms to be like this: 2 plus 2x over the quadratic form plus the constant here, which is 2 over 3 minus 2, which will be minus 4 over 3 over the quadratic term. The first one, what will be the result of the first integration? 2 plus 2x over, this is the derivative of the denominator. The result will be ln. So the first integral will be ln. We have made all these steps just to adjust the numerator to be in terms of the derivative of the denominator. Why? To the result to be ln. Okay? Now for the other term, which is a constant over the quadratic form, we have learned how to deal with a constant over 1 over quadratic or 1 over root quadratic. How would I deal with it? I just make complete square. And when I make complete square, the result will be in the table. It will be some inverse rule in the table, which will be tan inverse, or will be tanh inverse, or it will be sine inverse, or cosine inverse, or sine inverse. One of these 5 expressions in the table. Okay? So this is how to deal with expressions like these. Now, what if the integral had only the denominator was multiplied to by another bracket like this? When I have such expressions in the denominator, which is not simple, at first it was just a quadratic form, and I've learned how to deal with quadratic forms. But how would I deal with expressions with some other brackets multiplied in the denominator? This is dealt with a new method, which is partial fractions. What are partial fractions? Partial fractions is a method in mathematics which converts products of fractions to sum of fractions. Okay? It is just the inverse of another method or another rule in mathematics, which was common denominator. What was this? If I had an expression like this, 7 over x plus 2 minus 2 over x minus 5. If I had this expression, can I make this as a common denominator? Yes, how? It will be like this: x plus 2 multiplied by x minus 5. And this will be 7x minus 35. And this will be minus 2x minus 4. Okay, so the result will be 5x minus 39 over x squared minus 3x minus 10. This is making common denominator. If I had this expression in the first step, I need to make it like this. This operation will be called partial fractions. Partial fractions. This expression is just like this. It is 5x minus 39, and here are some brackets. So I can deal with this as a product of fractions, like 5x minus 39 over x plus 2 multiplied by 1 over x minus 5. These are two multiplied fractions. Okay? This multiplication or this product, I want to convert it to be a sum of simple fractions. Sum of simple fractions. How would I get this expression? This is what we will learn today. To make the expression to be in partial fractions, these are called partial fractions. Okay? To convert a product of fractions to a sum of fractions, of simple fractions. Each of these simple fractions can be integrated easily. I can't integrate this as easy as those. Maybe you can deal with this expression the same way we have dealt with this one, by expressing the numerator in terms of the derivative of the denominator, then making complete square. But if I dealt with it in partial fractions, just I put it in this expression, and each of these terms will be integrated easily as ln. So the result of this integration will be just as easy as 7 ln x plus 2 and minus 2 ln x minus 5. Okay? So this expression can be integrated by two ways. The first way is to make it as with this method by expressing the numerator in terms of the derivative of the denominator, then separating the integral to be two terms and making complete square in the other term. The other way is to deal with it in partial fractions, is to express this product of fractions as a sum of some simple fractions. Each of these fractions can be integrated easily by the table. Okay? Okay, so the first step in any partial fractions problem is the long division. First step is always long division. And when we perform long division, when the degree of the numerator is greater than degree of the denominator, greater than or equal to. Okay? The other steps cannot be performed in any expression with this condition. If I have, now we will learn some other steps. I can't perform any of these steps with a fraction with a degree in the numerator greater than or equal the degree in the denominator. What are the next steps? The next steps are to factorize the denominator to be a product of brackets. Okay? So, for example, I will have this expression x plus 2, x minus 1, x plus 1. Maybe it was something like this first. At first it was x plus 2 multiplied by x squared minus 1. And here I have x squared plus 2x plus 7. Would I apply long division in this expression or not? No. So now it is ready for any other steps after the long division. Okay? The first step is to factorize the denominator in the simplest form. So I have here a bracket which is x squared minus 1. I will just factorize it to be x minus 1 multiplied by x plus 1. Okay? So I have here something like this, x squared plus 2x plus 7. The second step is to assume the form of the fractions. And this is a very important step to make the assumption correctly. What is the assumption here? The first rule, if I have first degree brackets, any first degree bracket is converted to a fraction which has this form, x plus 2 with a constant above, plus b over x minus 1 plus c over x plus 1. I don't, when putting the assumption, when putting my assumption, I don't look at this numerator. It doesn't, the numerator doesn't affect these. Okay? I'm just focusing on the denominator. It is all expressed as a product of brackets, of first degree brackets or linear brackets. So every linear bracket is converted to its fraction, like this way, in this way. Okay? And each of these simple fractions, this is called a simple fraction. In a simple fraction in this form, the numerator must have a degree which is less than the denominator. So if this was a first degree term, a first degree bracket, so the numerator must be 0 degree, which is a constant. In any of these must be called simple fractions. Simple fractions. What are simple fractions? A simple fraction is a fraction which cannot be simplified in any more simple form. In a simple fraction, I will have with a denominator of first degree, the numerator must be a degree less than the denominator. So if the denominator had a degree 1, so the denominator must have a degree 0. Okay? So this is the form of the simple fractions for a denominator which is a product of linear brackets. Okay? Now the next step is to find the values of these constants. Now I have three unknowns. Okay? So I need 3 equations to find these 3 unknowns. We will learn first how, we will learn the logic for a method. We will learn a method called covering, which is easy and fast to find these, for this expression, which is easy and fast to find the value of the constant. But first we will learn the logic which it is based on. Okay? What is the logic to find these constants? It is called equating coefficients. What is that? It is just based on expressing this as x squared plus 2x plus 7 over these brackets Now this expression is equal to this expression for all x. For all x. Any x that is substituted in the left hand side must give the same result in the right hand side. This is what is meant by this identity or this equation. Now I just multiply by this denominator. I multiply the equation by this denominator. So the result will be x squared plus 2x plus 7 is equal to a. When I multiply this by this fraction, the result will be x minus 1 multiplied by x plus 1. Then the other term will be b multiplied x plus 2 multiplied by x plus 1. And there is a bracket that will be cancelled. Okay? When I multiply this by any of these terms, there is a bracket will be cancelled. And the last term will be c multiplied by x plus 2 multiplied by x minus 1. Okay, I have just here multiplied the equation by the denominator. Then, because I know that I can substitute for any x, this expression is equal to this expression for any x. I just substitute by any x I choose. I can substitute by any x I choose in both sides. But here I can choose some values which will make the equations very simple. What are these values? What if I substitute x is equal to minus 2? Let's substitute here x to be minus 2 in this right hand side. When I substitute x is equal to minus 2, what will be this bracket? It will be 0. And also this bracket will be 0. The only term that will not be 0 is this term. Okay? So now I managed to get rid of b and c in my equations. It will be only one equation in only one unknown, which is a. Okay? So now the first step is to substitute by x equals minus 2, both sides. So it will be minus 2 squared plus 2 multiplied by minus 2 plus 7 is equal to a multiplied by minus 2 minus 1 and minus 2 plus 1. So I managed to find the value of a, which will be minus 2 squared plus 2 multiplied by minus 2 plus 7 over the minus 2 minus 1 minus 2 plus 1. Okay? So this is the value of a. Similarly, I can find the values of b and c. What do you expect how to find the value of b? Now look carefully here. I found the value of a by substituting both sides. X is equal to minus 2. When substituting x equals minus 2 in both sides, I managed to get the value of a. What do you expect to substitute for x to find the value of b? X equals 1, yes. And to find the value of c, I substitute x equal to minus 1, yes. And this is the method of covering. This is the method of covering. What is the method of covering? To find the value of a, we just substitute in this expression. Now look, this expression is just like this. This one is just like this. But I didn't substitute in the bracket which was x plus 2. So what is the method of covering? I will write the problem again. X squared plus 2x plus 7 over x plus 2, x minus 1 Okay, what is the method of covering? Method of covering tells me that if I had linear brackets, so the constants of each of these linear brackets can be found by I substitute x is equal to minus 2. Where would I substitute x equal to minus 2? In this expression. But by covering the bracket of the A. Just by covering the bracket of the A. So I substitute x equals minus 2 in this expression without this bracket by covering the bracket which is x plus 2. Okay, so this will be minus 2 squared plus 2 multiplied by minus 2 plus 7 over minus 2 minus 1 minus 2 plus 1. Then I find this result. Now I want to find the value of b. I substitute x equals to positive 1. Okay, where would I substitute it? In this expression, only by covering which bracket now? What would I cover? The second, yes, the second bracket. Now I would cover this bracket, and I substitute in all of it but this bracket. So now I substitute for x equals 1, x equals 1, it will be 1 squared plus 2 multiplied by 1 plus 7 over 1 plus 2, 1 plus 1. So this will be the value of b. Then I can find the value of c, which will be x. I substitute x equals to negative 1 in the expression, in this expression, but only by covering this bracket. It will be minus 1 squared plus 2 multiplied by minus 1 plus 7 over minus 1 plus 2 and minus 1 minus 1. Okay, then I get this value. Now can I integrate this expression? Can I integrate this expression? Integration of x squared plus 2x plus 7 over x plus 2 multiplied by x minus 1 multiplied by x plus 1. Can I integrate this expression? Yes. How? I just made the partial fractions. I had this value of a. Now I have these values as numbers. Okay, the result will be a over x plus 2 plus b over x minus 1 plus c over x plus 1 dx. What will be the result of the integration? It will be all lens. Okay, ln x plus 2 b ln x minus 1 plus c ln x plus 1 all plus c. I will just say c dash to make a difference between it and the other c. Okay, now I've learned how to make partial fractions for simple linear brackets. Simple linear brackets. Another form for partial fractions if I had this expression. Now this integral is just a polynomial over polynomial, but now I have a denominator which is a product of the bracket, polynomial brackets. So now I think of partial fractions to convert this product of brackets to a sum of fractions. The first step I said to do is to check, will I use here long division or not? No, there is no long division here. If the expression was like this, x squared plus x over x minus 1 x squared plus minus 9 plus 9. Would I use here partial fractions or not? No, I will not. Why? Because this is still second degree and the denominator is the third degree, so there is no long division. No long division. If the denominator was x power 3 minus 2x over x minus 1 multiplied by x plus 9, would I use long division here? Yes. The first step here is to make long division. The first step here is to make long division. If I start to make the assumption on this expression, all my steps will be wrong. Any of these steps, which is the assumption, my assumption, then the substitution to find the constants, all of these steps will be wrong if I forgot to make the long division step here. Because here I have a third degree divided by a third degree, so the first step is to make long division. If I forgot to make long division, any of the following steps will be wrong. Okay? So it is important to check if I will make long division or not. So now in this expression, I will not need to make long division. So no long division. No long division. Okay. So what is the next step? The next step is to factorize the denominator. So the denominator is factorized to its simplest form. Can I factorize this bracket? Can I factorize this bracket? No. This bracket is called non-factorizable. It's a second degree bracket, non-factorizable. Non-factorizable bracket. How would I know if some second degree bracket or some quadratic bracket is non-factorizable? How would I know this? If I had, for example, x squared, if I had x squared plus x plus 1, is this factorizable? Can I factorize it or not? How would I know if it is factorizable? Any of you know if this is factorizable or not? This expression is also non-factorizable. Non-factorizable. How would I know if it is non-factorizable? By, do you know the discriminant, which is b squared minus 4ac? Do you know what is this? If I had some quadratic form, a plus bx equals b plus c equal to 0. What are the solutions of this equation, quadratic equation? X is equal to minus b plus or minus b squared minus 4ac. Do you know this rule or not? This is a known rule for quadratic equations. Okay? Now, if this is called the discriminant. If the discriminant is negative inside the root, means that the solutions will be complex. I equal to root minus 1. This is called complex numbers. Okay? But for our real analysis, that will mean that this expression is non-factorizable. So when is a bracket non-factorizable? When b squared minus 4ac is negative. If I have b squared minus 4ac is negative, so this will be non-factorizable bracket. If I check this one, b is equal to 1. So b squared minus 4ac will be 1 squared minus 4 multiplied by 1 multiplied by 1, which will be minus 3. So this is negative, so I have known now that this expression is non-factorizable. One of the most common forms for non-factorizable quadratic brackets, which has this form, x squared plus a squared. This is most known expression for non-factorizable brackets, quadratic brackets. Why? Because this cannot be 0, cannot be equal to 0 unless for complex values. Okay, so now these two brackets, I'm just saying this, that these two brackets are in the simplest form. These two brackets now are in the simplest form. Now I'm ready to make my assumption for the fractions. What will be my assumption? It will be like this. The first bracket is a linear bracket, so its simple fraction will be, the corresponding simple fraction will just be a over x minus 1. The second bracket, the fraction corresponding to it will be x squared plus 9, but the denominator, what will be the numerator here? I want to make this as a simple fraction. I have the denominator with the second degree. What do you expect will be the degree of the numerator? Degree 1. So my assumption will be bx plus c. Okay, now I have to pay attention in my assumption. If I made the assumption in a wrong form, all my further steps will be wrong. Okay, now I have 3 unknowns, so I need 3 equations to find these constants. The constant of the first degree bracket can be found by covering, as we have learned in the previous problem. So I can find a by substituting x equal to 1 in which expression? In this expression, but by covering this bracket, which is the bracket of a. Okay, so I just substitute x equals 1, it will be 1 squared plus 9, which will be 1 over 10. So I've managed to find the value of a. Now I still have two constants that I need to find its values. How would I do this? I need 2 equations. To find these 2 equations, I can make it by any of 2 methods. The first method, I will just write the problem again. 1 over x minus 1, x squared plus 9 equal to a over x minus 1 plus bx plus c over x squared plus 9. Okay, and we have managed to find a is equal to 1 over 10. Okay, now I need to find a method to find a, b, and c. How would I do this? The first method is simple. It is called by substitution, both sides. It is just based on the fact that this expression is equal to this expression for any x. I need 2 equations, so I just substitute for any 2 values of x in both sides to find these 2 equations. Then I would solve the resulting equations to find the values of b and c. Okay, so I can choose any values that would I like in both sides. Okay, but just don't use any value of x that you have used before. Did we use any value of x before? Yes, we have used x equals 1 in finding a. So I'm not allowed to use the value of 1. I'm not allowed to use the value of 1. Okay? I choose simple values of x. So for example, I didn't use x equals 0, so let's use x equals 0 both sides. X equals 0 both sides. So it will be 1 over minus 1 and 9 equal to 1 over 10 multiplied by divided by minus 1, and here we have c and 9. I multiply by 9 both sides, so I would have c. I can find the value of c. Okay, so I managed to find the value of c by substituting x equal to x equal to 0. Okay, now I choose another value to get the second equation. I choose another simple value of x, which may be x equals minus 1. You may choose any value you would like, but not 1 or 0 here. I just choose x equal to minus 1 both sides, which will have x over minus 1 minus 1, and here we have 10 equal to 1 over 10 divided by minus 1, which will be minus 2, plus b multiplied by minus 1, which will be minus b, plus c over minus 1 squared plus 9, which is equal to 10. And I have managed before to find the value of c. So I know the value of c, so now I can get the value of b. Okay? So this method is called substituting both sides. By substitution both sides, I just choose any values for x both sides to find the missing unknowns. Okay? What is the second method to find the values of b of t? It is called equating coefficients. So I will write the problem again. 1 over x minus 1 multiplied by x squared plus 9 equal to 1 over x minus 1 plus bx plus c over x squared plus 9. And we have known that a is equal to 1 over 10. Okay. Now I need to find b and c. The first step in the second method, which is called equating coefficients. Equating coefficients. Equating coefficients, first we have to make this as a polynomial equal to polynomial, not a fraction equal to sum of fractions. Just I want to make it both sides are polynomials. How? By multiplying both sides by this denominator. So I multiply both sides with this denominator, which will be 1 is equal to a, which is 1 over 10. When I multiply this denominator by the first one, the bracket of x minus 1 will be cancelled. So I will have here x squared plus 9. And in the other term, I will have a bracket which is bx plus c multiplied by, now it will be multiplied by only this bracket, which is x minus 1, because the other bracket will be cancelled. The bracket of x squared plus 9 will be cancelled when it is multiplied. X squared plus 9 will be multiplied and will be in this form. Okay? Now I look in this equation. This is called identity. Identity, which is equal for all x. For example, when I have ax squared plus bx plus c equal to 1 minus x squared, and I told you that this is an identity, this is equal for all values of x. You need to differentiate between two kinds. When I tell you that this is an equation in x, when I tell you this is an equation in x, so I need you to find the value of x which makes this equation valid. So if I told you this is an equation in x, we need to find just the values of x. What are the values of x to make this valid? It will be discrete values of x, so maybe one or two values of x. But when I tell you that this is identity, what is meant by identity? It means that this expression is equal to this expression for all x. It is identical. Both sides are identical. When both sides are identical, what would I expect here? That a will be equal to a, which is the coefficient of x squared in, I'm telling you that this side is identical to this side. So the coefficient of x squared here will be identical to the coefficient of x squared here. What is the coefficient of x squared in the right hand side? It will be -1. And what will be b, the value of b? It will be 0. What will be the value of c? 1. So this is how would I deal with an identity. What is meant by identity? It means that the expression is valid for all x. It is not an equation. This is not an equation in x. When I tell you that this is an equation in x, it means that I need to find the values of x which makes this expression valid. This is not the case here. The case here is I'm telling you that this is an identity, which means that both sides are identical. When both sides are identical, I just compare the corresponding coefficients of x. So I have here a second degree. What would I do in this expression? I equate coefficients of powers of x. What is meant by that? I equate coefficient of x squared both sides. I equate the coefficients of x power 1 both sides. And I equate the coefficients of x power 0 both sides. Okay? I will make this as a, just to put some point here. I will tell you some point here. Okay? Now I want to equate the coefficient of x squared both sides. What is the coefficient of x squared in this side? It is 0. So 0 is equal to what is the coefficient of x squared in the right hand side here? It is a, only a. It is only a, or can I find some x squared?
B.
Yes, I can find a term which gives x squared by multiplying these two terms. Yes, so I have here a plus b. So I have here a plus b. So this is the first equation. This is the first equation. The second equation, which is by equating coefficients of x power 1 both sides. What is the coefficient of x power 1 in this side or in the left side? It will be also 0. So 0 is equal to, what is the coefficient of x power 1 in this side? I don't have here x power 1, but here I can find x power 1. How? By multiplying this by this only, or can I find another term? I can multiply bx by -1. So these two terms will give me an x power 1 term. Okay, so I have here bx multiplied by -1, which will give me -b. And another term which will c multiplied by x, which will give me a c, plus c. So this is the second equation. What is the third equation? which is equating coefficients of x power 0, which is the constant. X power 0 is the constant, both sides. The constant in the left hand side will be 1. The constant in the right hand side, would this give me a constant? Yes, it is 9a. For this term, would this product give me a constant? Yes, which comes from c multiplied by minus 1. It will give me minus c. So now these are the three equations in the three unknowns, which are a, b, and c. Okay? So by solving these three equations, I will get the values of a, b, and c. Okay? Now, we have managed before to find the value of a by covering. So by these equations, I make it as a check. Or if I have known the value of a, I will just get here the value of b. When I know the value of b, I will just get the value of c, and the third equation will just be a check for me. The third equation will just be a check for me. So what is the difference between these two methods? The first method is called equating. The first method was called the substitution, both sides in x, a value of x. I have chosen random numbers for x, but that were not used before. And for the second method, which is equating coefficients, I found three equations in the three unknowns by equating coefficients both sides. Usually, if we have the equations coming from equating coefficients are usually simpler than the equations coming from the substitution, unless if I had a value of 0 that was allowed for me to use, that would make the steps simpler. So anyway, you are free to use any of these methods by substitution both sides or by equating coefficients. Okay, but you have to learn both methods. I would require in the problem, I will tell you solve by equating coefficients, or find the constant by equating coefficients, for example. Okay, so I have to study both methods. I need to have the skill of finding the values by either this method or the other method. Okay? Now all of these steps are just finding the partial fractions. What about the integration itself? What I have done here is that I have managed to put the integral, which in this form, I just managed to put it in this form. And I have found the values of a, b, and c. So now this is the integral now, and I know these values. These are numbers now. Okay, how would I find the integral? The first term, what is the integral of the first term? It will just be ln. What about the second term? This is linear over quadratic, and I've learned how to deal with linear over quadratic. Linear over quadratic, I just make the form, the linear form, express it in terms of the derivative of the denominator. What is the derivative of the denominator here? It is 2x. So I find 2x, I will express the integration as integration of, I will take b out. I will be b x plus c over b. then I would multiply by 2. Multiply by 2, then divide by 2. Why would I do this? Just to get the expression which is the derivative of the denominator. Okay? So this is the derivative of the denominator. Now I separate the fraction here. So it will be 2 integrals, which will be over 2 multiplied by integration of 2x over x squared plus 9, plus the other integral, which is 2c over b, integral of dx over x squared plus 9. This will just be ln x squared plus 9. And this is a constant, 2c over b. What is this integral? It is tan inverse 1 over 3 tan inverse x over 3 plus c, all multiplied by b over 2 and this term. If the denominator was x squared plus 3x plus 9, and that was the integral, how would I deal with this? Completing square, yes. Completing square. Okay? So now we have learned how to deal with two forms. The first form was linear brackets, and this is solved. All the constants can be found by covering linear brackets. Okay? The other form that I've learned, if some of the brackets are quadratic, non-factorizable. And I've learned how to make my assumption and how to find the values of the unknowns. The third form that I would learn is when I have a linear bracket but raised to some power. For example, if I had x minus 1 multiplied by x plus 1 all power 3. Okay? If I have this bracket and here I have something like this. First, would I use here long division or not? No long division here. The degree of the numerator is 2 and the degree of the denominator is 4. So there is no long division here. Okay, so it's ready to make, I'm ready to make the following steps. The first step is to put the denominator in its simplest form. Factorize it and put it as a product. And this is also, it cannot be factorized further. Cannot be further factorized. So I am now ready to make my assumption. I just need to put x squared plus 1 over x minus 1 multiplied by x plus 1 or power 3. What would be my assumption here? The bracket, which is first degree a linear power 1, it will just be a over x minus 1. What about this new form? It is a linear bracket but raised to some power. When I have a linear bracket raised to some power, it will give me number of fractions as the power. Okay? What are the forms of these terms? It will be a constant. It will be a constant b over x plus 1 to the power 1. And the other will be c over x plus 1 all power 2. And the third will be d over x plus 1 all power 3. Okay? So I assume number of terms as exactly the power of the bracket. Okay? Now each of these fractions are put in the form by only looking inside the bracket. For example, I don't say here that the denominator is a second degree, so I put the denominator in cx plus d. No. When I have a linear bracket raised to some power, each of these terms will just deal with the denominator as if it was a first degree. Okay? So it will be just a constant. It will be just a constant here and here. Okay? And I remember that I would have three terms. I would have three terms for this one. Okay? Now some of these constants can be found by covering. One of them I've learned before, which is, which one would I find, could I find it by covering? A. This is which was corresponding to the first degree term. I have learned any first degree bracket, I can find its constant by covering easily. So I can find A, I substitute x equal to 1 in this expression, but by covering the bracket which is x minus 1. So I just substitute here 1 plus 1, 1 squared plus 1 over 1 plus 1 all power 3, which is the value of, which will be the value of A. So now I found the value of A. One of these three can be found by covering. The covering method is an easy method. I can make benefit from it to find any of these. It will make the equations, the incoming equations, simpler. So can I find one of these three can be found by covering? Which one of them is found by covering? Which had the same expression as this. Why? So I could cover it. So which one of these is exactly the same as this bracket? D. So this is found by covering. So I just look for the term which has the same expression for the bracket, which is here, it will be D. Why? Because I need to cover it. So I need to cover the exact expression for the D. I don't have here exact expression for x plus 1 or power 2. I don't have this expression exactly. How would I cover it? And there is also one, this will be 2 if I express it as x plus 1 plus 2, x plus 1 squared multiplied by x plus 1, I will have a problem of substituting 0 in the denominator. It will be full of problems. So it is only applied in D. So I can find now the value of D. I substitute x equal to -1. I substitute x equal to -1, which makes the denominator to be 0. Okay, I substitute it in this expression just by covering this bracket. So now this will be -1 squared plus 1 over -1 minus 1. And the result of this will be 2 over -2, which will be -1. So now I've managed to find the value of A, which was 2, and I've also managed to find the value of T, which is -1. I still need two constants to find. Okay? I can use any of the two methods that I have learned, by substitution or by equating coefficients. Okay? Because they are only two constants, I can use substitution. Instead of making the steps of equating coefficients, then find the 4 powers x power. Now it will be x power 4 and x power 3 and x power 4, all of these. Now instead of all these, I will just find I will just get two equations exactly by substituting two values for x. This is sufficient for me. I can find here, or I can tell here that the substitution method will be easier. So I choose some value of x that I didn't use before, a simple value of x that I didn't use before. What would I substitute here for x? I have used before x equals 1, and I have used x equals minus 1. 0. Yes, the simplest form is the simplest value for x is 0. Unless I had used it before. So I substitute x equals 0 both sides, which it will give me 1 over minus 1 multiplied by 1 cubed equal to 2 over minus 1 plus b over 1 plus c over 1 squared plus d, which is minus 1 over no, this a was 2. This is 2? No. Okay. D is equal to minus 1 over 1 cubed. So this is the first equation, which is b plus c equal to minus 1 plus 2 plus 1, which is 2. So we have now an equation which is b plus c is equal to 2. We have here an equation b plus c equal to 2. Now I need another equation. I have used 1 and I have used minus 1. What would I use here? X equals 2. I substitute x equals 2 both sides. So now I have 5, which is 4 plus 1 over 2. It will be 1. 2 minus 1 is 1. 2 plus 1 is 3 cubed. Equal to 2 over 2 minus 1 is 1 plus b over 3 plus c over 3 squared plus d, which is minus 1 over 3 cubed. And I can multiply 3 cubed to both sides, so I have now 5 equal to 3 cubed. What is 3 cubed? It is 27. So 2 multiplied by 27 plus b multiplied by 9 plus c multiplied by 3 minus 1. So this is the second equation. I solve these two equations to find b and c. Okay, we solve these two equations to find b and c. Okay, now we have done the partial fractions. Now I need to make the integration itself. So I write it again. Now it is integration x squared plus 1 over x minus 1 multiplied by x plus 1 over cubed dx. I have managed to make it in as a sum of fractions like this: x minus 1 plus b over x plus 1 x plus 1 over c over x plus 1 squared plus d over x plus 1 over cubed. Now I have now all the constants a, b and c as numbers. Now I want to find the result of the integration. What is the result of the integral? The first will be ln a ln x minus 1. The second will be also ln x plus 1. The third will be, no, it is not ln. It will be, this is a linear bracket raised to some power. linear bracket raised to some power, so I use the power rule. This is all raised to power minus 2. So it will be x plus 1 power minus 1 over minus 1. Do you remember? The first generalization, which I have a bracket, a linear bracket instead of x. So I can now use the power rule. Power rule, add 1 to the power and divide by the new power. And for the last term will be, this is x all power minus 3. So it will be x plus 1 raised to power minus 2 over minus 2. And I have the values of a, b, c, and d. So this is the result of the integration. Okay? For this integral, first step, would I do here long division or not? No long division here. Okay. Second, would I further factorize the denominator? Yes, I need to factorize the denominator. It will be x minus 1, x plus 1, x minus 1. Would I leave it in this form? No, we have two identical brackets here. We cannot make it as this. I can't deal with them as different brackets. I can't. Some students make it like this, put the assumption like this. Is this correct? No. Why? We have here two identical brackets. When I have two identical brackets are put all in one bracket but raised to its power. So this will be x minus 1 all power 2. So this is my final form for the fraction. Now I need to put my assumption. For the fractions, which will be, I have here a linear bracket, so it will be a over x plus 1. Now for this one, how would I make my assumption? We have two terms. Yes, because here I have a linear bracket raised to some power. So it will be x minus 1, and the other term will be x minus 1 all power 2. What is the denominator here and here? It will be a constant or a first degree term? It will be constant. So this will be b and this will be c. So just pay attention that here this term is different from this. Never use this expression. Now which of these constants can be found by covering? Yes, A and C by covering. It will remain only one constant to find, which is B. How would I find it? By substitution both sides by some value. What value would I use here? 0, yes. I use B by substitution x equals 0. It will do here. Okay? Now after I manage to find these constants, can I find the result of the integration? Yes, the first term will be a ln x plus 1. The other will be b ln x minus 1. The third will be c raised to negative 1. Yes. and I have these values as numbers. Okay? So we have learned today how to deal with the three forms of the brackets in the denominator for partial fractions. Okay? There are some cases, some other cases. These are the three basic forms. What we have learned today are the three basic forms for the partial fractions. In the next integration lecture, we will just find some other cases which can be transformed to any of these. Okay, we will learn this in next lecture in integration. Okay, but just study this lecture in integration, which has the three basic forms: a linear bracket, and non-factorizable quadratic bracket, and a linear bracket raised to some power. Okay, these are the three standard forms for the simple fractions that we have learned today. Okay, we will have a break 10 minutes.